everybody. Everything but wood. I took that literally, everything but plants. That's the approach that I included. You are going to hear about bone char from me. So something that does not really match biochar, but it's still an interesting feedstock, and that is relevant, a relevant feedstock and material. And I'm going to explain things to you in the upcoming 30 minutes.
Wenn wir von Schlachthöfen sprechen.
So when speaking about slaughterhouses, processing animal food in order to produce what we see in the grocery store, you know, there are residues. We might think this is material that we use for fodder production, but not everything left there can be used for that. So the residue in a slaughterhouse are split in 3 different categories. And it's only the 3rd category that is appropriate for food and fodder, while the first 2 categories cannot be used for fodder or food. And part of that are also material, bouillons, and so on, and that can be dangerous. And these are large amounts of residues that are incinerated. So the nutrients in these materials are incinerated and are lost. In order to make use of that type of material, we set up a scientific research cooperation together with the slaughterhouse, testing several approaches and methods. This slaughterhouse is open for circular economy, and it was proactively involved with a biogas system using the aqueous residues for, as I just said, biogas production, and make use of it on an energetic level, supplying the slaughterhouse with energy in order to make sure that they can further continue the residues in the manure after fermentation. But this is not it. Not everything is liquid. Speaking of bones, of shoes, and whatever material that cannot be used elsewhere. And these solid residues, and to make use of them using pyrolysis, this was the launching point for our project. So this is an illustration of what we did. So the animals are cut in the slaughterhouse. We have materials that can be used for food or fodder, and that can be digestated, and that can be pyrolyzed. When speaking about the liquid residues and processing them in an anaerobe way, we have the biogas digestate manure that can be used in agriculture. But when it comes to the content, you know, we have high losses of nitrogen, and we want to reduce that loss, and that is part of the overall goals of this project by producing a fraction rich in nitrogen and a fraction poor in nitrogen. And later on, we enriched the bone char with nitrogen. And we tested things also with regard to their impact on plant growth. So how can you make use of biogas digestate into fractions with different nutrients? We can use membrane distillation, so a semi-permeable membrane On the one side and on the other side, you have a temperature difference. And given that in the biogas manure and in the digestates, a part of the nitrogen is included in NH4 plus, substances pass the membrane and are then captured by a sulfate liquid with a fraction of 8 to 10 gram NH4 plus in this residual manure. When it comes to the solid fraction that we want to process, so we used a pyrolysis reactor and scaled it in a larger system. And also this type of coal or char was analyzed. If we take a look at the type of chars that is available as a result, it is different. The result is different from the pyrolysis result of plants. So in the first row, well, we thought we want to make sure that we increase NH4 plus absorption and not rely on the fresh bone char only, but we want to activate it additionally with water, vapor, or also with other substances. And if we take a look at the water vapor, you know, the char is almost white. So it's less than in plant char and biochar, and it's less stable. Is the lignin structure of a plant is very important to make sure that the biochar provides a stable connection that can remain stable within the soil. When it comes to bones, we have different nutrients and different elements and in different connections that then evaporate later on. We analyzed the material, also asking ourselves about the applicability for agriculture, and one of the parameters is the water holding capacity that you see here. We said that when it comes to with regard to the amount, it's 120% of water holding capacity, WHC, so half of the dry matter can be stored as water. We also saw that the additional treatment steps improving the NH4 plus absorption provide also disadvantages. Apart from the original material, and we found out that 500 degrees is the best approach in order to generate a result and a bone char with a good water holding capacity. This title is not carbonization only because compared to the pyrolysis of plants and the nitrogen and the carbon content is different. So the question is whether we pyrolyze the material right from the beginning. And the different bars that you see here are the different parameters that we tested, including several activation steps. And what you can tell right away is that the different parts of the animal body that the residues come from differ. Heads, that means the head and also the jaws. Feet means also, so feet include also the hooves. And when it comes to the ribs, we only refer to bones. So we have different materials available, and the contents are volatile in different ways. We lose carbon 20-25%, and it goes down to 15%. And for the feet, including the hooves, it stays up to 20%. So the higher the temperature goes, the more loss we see. The small bars is 900 degrees. That's where we see a major loss of carbon compared to treating plants. But you also have to make sure and understand what type of residue you use as a feedstock. Bone char is not the best material, that is clear, in order to reach the balance of a carbon footprint. You know, it's easy to calculate. 11.4 tons, that's the average footprint per person in Germany. In order to compensate with biochar, you would need 4.3 tons. For bone char, 15.5 tons. So it's not realistic, but bone char should be used for nutrient recycling, not so much for carbon purposes. But so if we want to result in have a material a material at the end of the day rich in carbon, we have to ask ourselves, what else can we use? We have additional material that we can use in slaughterhouses that is also plant-based, that adds carbon, adding also other nutrients. So we have coal up to 50-60%, and these are those that use this type of waste of a slaughterhouse, using also the bedding of the animals, while the bones themselves, 10-20% is what they deliver. 50-60% when making use also of the bedding. And we see also the loss of nitrogen that we're familiar with when processing plants also. Now let's speak about phosphorus. 12-14% overall amount in the bone char available, and the bedding material that are good for the carbon content are contain only 1-2% of phosphorus, but their strong suit is their carbon content anyway. And there is also a difference between pig and bovine bones, also depending on the methods used in the slaughterhouse. So 12-14%, not everything is readily available for plant. Calcium phosphate, for example, only 1-2% phosphorus contained in the char, in the fraction that is available for plants. Comparing the temperature, 350-650, the lower the temperature is, the higher the share is, but still very small in absolute amounts. We heard today already, and this might also be a topic for biochar, and there are technologies where you can add substances and increase the content, but this is not something that we tested. I differentiate between the plant available phosphorus that can be dissolved in citric acid and is used for simulations, and the water soluble content, you see 1-2% here. For the first extraction, it's not very much, but it might be even more also when it comes to the water-soluble aspect. It depends also on the availability of other fractions that we might use. If we take a closer look and ask ourselves whether this might be a replacement for mineral fertilizer, we are not that far away from what we actually need. I brought for you the average need in fertilizer of a general crop 20 to 40 kg of phosphorus. And I suppose that we add 10 tons bone char. Whether this might be realistic in or not, this is something that can be discussed, but this is just an example. So when it comes to the bovine bones and the fraction that is available for plants, we can reach that amount, as you can tell from the table here. So it is a replacement that can cover a significant part of the mineral fertilizers for the need of crops in phosphorus. The second nutrient, this is nitrogen. We speak always about ammonium because in biogas manure, we have ammonium as the prevailing nitrogen substance and nutrient, also the one that we find before the membrane distillation, so ammonium sulfate. So if you do not apply any further treatment of the bones, you reach 1 to 2 milligram ammonium per gram. That is not very enthusing, but I have to say that that was a diluted liquid, way more diluted than the one that we find in our biogas manure fraction. If you increase that to 10 gram per liter, so this is what after the membrane distillation results in the digestate. We reach 40 to 50 ammonium per gram bone char that can be transsorbed. And this is an interesting amount, but we have to say at the same time that this goes only for the additionally activated chars. When it comes to the water vapor or the other substances, we have seen only very small result. So vapor is not really an option. So we need to stick to leach as a preparation for ammonia. What else did we do? We did competitive tests with other ions. 1/4 is lost if we have equally molar conditions, but it is more than half of what gets lost. And here we took a look at the type of ammonium salt, ammonium chloride, vis-a-vis ammonium sulfate. With sulfate, you reach similar absorption values compared to chloride, like we did in the first absorption test that we carried out. And of course, we wanted to know about the availability for the plants. These are standardized and modified Neubauer tests. So whether plants grow in a substrate and then they get their nutrients from a nutrient liquid, and that has to be free of nitrogen, of course. The differences can be seen in the gray bars. These are the plants that made use of all the other nutrients apart from nitrogen. Red bars is bone char from the scalp, from the jaw. Green is bone char from ribs, and the lighter color shows an addition of 3%. A surprise that we saw is there are chars that present obstacles. And we can make sure that we overcome this type of restraint or inhibition with other substances. So this is a monosulfide liquid that we enriched it with, so we can resolve that problem, and then ribs and scalp bones cannot be differentiated anymore. We get an absorption of nitrogen, as you can tell here in the chart. The darker bars show the amount of char. So 3 times the amount of char does not result in 3 times the amount of carbon, given that it was a short-term test trial. So the plants include nitrogen, they can take it off the char, so to speak, and we need to make sure that we understand what char we use to produce it. And something that we have not been working on yet is the question whether we can generate phytotoxic chars from those bone. So solid residues of a slaughterhouse can be used in order to recycle the nutrients much better than incinerating the residues. Of course, you have to process things in order to improve the content. You have to take care of the temperature in order to produce 40 to 50 gram sorption potential. This is another result, and the plants can then make use of the nutrients because it is plant available. So I hope I took care of the non-vegetarian fraction of the audience with my presentation. Thank you for your attention. We have questions. Thank you, Professor Soja. Gerhard, this is very courageous, a very courageous field of research. So if I take a look at the approval cycle, for example, when it comes to pyrolyzing horse manure, I'm looking forward to the reaction of the authorities with regard to this type of residue. Is legislation different from Austria? Oh, Austria is truly complicated. You have to analyze a lot of things in order to prove that all these nutrients that the authorities are afraid of can be destroyed. We heard today, and I love that even the PFAS PFAs do not survive pyrolysis, even though they are considered very resistant. So the Bryan family, the different veterinarian medication, the residues of drugs, they will not survive pyrolysis. And we can make use of those things also and apply them also in agriculture. Other questions from the chat? Thank you. 2 questions. I would like to cluster them. And during pyrolysis, did you come across any problems with corrosion? What about raw gas values? Did you have to treat exhaust gas? Exhaust was not measured because most of the pyrolysis was done with our own reactor, and that is optimized for a certain process. It is not a realistic depiction of the energy household of the system. Corrosion problems come up whenever you work with a modified material, or if you want to work with this. Gerhard Dunst, who carried out a couple of trials for us, spend quite some time and sweat for on these things. If you work with pre-treated substances and add them to the reactor, you get severe corrosion problems, but not necessarily from the chars that have not been pre-treated. Thank you so much. Second question refers to the bones. Did you add any additional material in order to transfer them to a different calcium phases in order to improve the availability of phosphorus? We would love to do that, but at the time, this was not included in the test setup because we wanted to run a first test to understand how things go. But it's obvious that this type of steps are needed. And of course, there is potential for more. Let's continue with Professor Kammann. Thank you, Gerhard, for this non-vegetarian presentation. Very interesting. One question, similar direction as the one we heard before. So how can we improve N availability of bone char? There were publications for with wood char by oxidation, mild oxidation, with hydrogen peroxide, that you can improve the absorption capacity for NH4+. You tested KOH and water vapor activation. Would that be also an approach, or wouldn't it not be useful? It would be realistic, and it's worth trying. Activation with acid that Gerhard did, that goes along with so much loss in the char. So the yield goes down, apart from corrosion problems that you get. But with oxidative substances, you're right, that might be worth trying.